Hi, welcome to Advanced Math, Chapter 12, Part B, Page 2, where we talk about some simple vector addition and other operations like that. And I'm looking at a couple of vectors, vector u, which is this long and it's headed to the upper right, and vector v, which is a little bit longer and pointed in the upper left direction. We're going to add these two vectors together and get the resulting vector u plus v. How does that work? Well, a vector is a direction and a length, like I said, or a magnitude and a direction. And we could think of it as walking a path. So let's say we took this vector, which has a direction and a length, and we wrote a copy over here. Now, vectors don't have a place per se. They don't have a location. They just have a direction and a length. So we could take vector u and write it over here, and it means the same thing as this vector u over there. Now notice I'm using this notation in my writing of a lowercase u with an arrow over it to indicate it's a vector u. So vector u starts here. That's beginning our path. It goes in this direction and it goes this far. Once we've gone and traversed or moved this path from beginning to end for vector u, let's go and tack on vector v. So vector v starts where vector u finished, and it goes in vector v's direction, and it goes as far as vector v goes. So this is the same length as this vector v, and it's in the same direction. It started where vector u ended, and it goes up to here. So we've walked basically this path, two paths, a path for vector u and a path for vector v. Where do we end up? We ended up here. So that's equivalent to a path that starts here and goes directly to that endpoint. And the vector that does that, that starts here and goes to the end of where those two paths ended, that's a vector that represents the sum of u and v. So if you want to show graphically how you add vector u and vector v, you can do it this way. You can draw those two vectors together, head to tail like this, so that they make a single path from start to finish. And then the resulting vector, the sum of those two, has to be drawn in at the beginning, from the beginning of the first one to the end of the second one. And the length of this vector has to go from the beginning to just the end and no farther. And it has to have an arrowhead that shows you that you're going from here to here. And that vector we can label as u plus v. So that's the vector that's equal to u plus v. Okay, here's another example. If you want to talk about subtracting vectors, what you're really doing is you're adding a negative vector. And if you want to add a negative vector, you need to have a concept of what a negative vector means. So a negative vector has the same length as the original vector, but its direction is opposite. So here again, we've got a vector u, which is this long and goes to the upper right direction. It's going in this direction. The negative u vector would have the same length as a u vector, but its direction would be exactly opposite. So if we wanted to talk about adding a negative vector to a positive vector, we first need to create the negative vector, and then we can add it using the same technique that we used up here. If you want to multiply a vector by a number, so a number, when we're talking in the context of vectors, an ordinary number like 5 or 2 is known as a scalar. Scalar. So that distinguishes a regular number from a vector. Scalar is just a single number. So if we had a vector u, this is shown an example of vector u, and we want to multiply it by the number 2, or a scalar 2, we're really saying that we want to add u to u. So two u's added together is the same as 2 times u. So adding vectors we know how to do, and I'm going to show you this example. So I've got my vector u on the left, which we looked at. If I want to add two of them together, I'll draw them in that head to tail fashion. So I'll start down at the bottom of my box, and I'll draw my first vector u that represents a copy of the original, and then I'll draw a second one. on the end of the first one. So there are two u vectors drawn end to end. And I'm adding them together to get 2u. So my final resulting vector would be the one that starts where the first one started and ends where the second one ended. So that vector represents u plus u, or 2 times u. So again, if you were showing how you would get 2u from a single u, what I've drawn here is a two-step process. I've sketched in two copies of u end to end to figure out how long the sum is and in what direction. And then finally in red here, I've drawn in the final u plus u, or 2u vector. That 2u vector, that red vector, is 2u. That is the vector that's equal to 2u. These blue vectors were what I used in order to create it. Okay, that's the end of page 2. Page 3, we'll continue with some more examples like this.